All right, this video is going to look at voice onset time and its mirror voice offset time in terms of how they work and how we get things like aspiration and voicing contrasts in languages like English and many other languages that have a difference between voiced and voiceless consonants, voiced vowels and voiceless consonants, that sort of thing. Um, so first of all, we're going to set up kind of a visual way of thinking about this. So if you look at this illustration, this is just an illustration of sort of two things that are happening when we go from a sound like the voiceless bilabial plosive to the voiced post-front unrounded vowel E. In the oral cavity, above the larynx, for the P, we have bilabial closure. The lips are closed. And then when we move to the E, to the vowel, the lips open and we get this close front unrounded posture of the tongue and lips for the vowel. At the glottis, in the larynx, the P is voiceless, so the vocal folds are apart. And then as we move into the vowel, the vocal folds come together and start vibrating. So it becomes voiced. And you can see that illustrated sort of schematically here. This isn't a picture of what's happening, but it's a representation as we move from left to right through time. Now, we're going to start playing with this scenario a bit to look at different types of sounds. So first, let's just reference, we're going to use the moment that things change in the oral cavity as a reference. So when the oral closure ends, that's our reference point in time. And we're going to compare that to the onset of voicing. This is where we get the term voice onset time, right? When does the onset of voicing happen relative to that event in the oral cavity? So one possibility is that they happen at the same time. We call this zero voice onset time. Mathematically, we take the onset of voicing, what time that happens, we subtract our reference time, the time when the bilabial closure ends, and if they happen at the same time, those are the same time. So we subtract one from the other and we get zero. Zero voice onset time. And this, somewhat paradoxically, for those of us who come out of knowing English as a first language, this is a voiceless consonant and it sounds like B. So it actually sounds like our phonologically voiced consonant, the B. But phonetically, this is a plain voiceless consonant. So plain as in it doesn't have any aspiration or other stuff happening, but it is voiceless because the voicing happens entirely outside of that closure period. It's not happening during the constriction of the consonant. Now, if we were to use another scenario where the thing that happens in the glottis, the onset of voicing, is pushed later, as we see here, then we have this interval between the opening of the oral cavity and the onset of voicing, where we have essentially a voiceless vowel. And some narrow transcriptions, you'll actually see it transcribed that way. But this is what we call aspiration. We can also call it positive voice onset time because our onset time is later, higher time value than our reference time. So when we subtract them, we end up with a positive number. Now, it could be a millisecond later, and that would technically be a positive number, but generally it has to be 40 or 50 milliseconds before we notice this. So we don't tend to transcribe aspiration until we have at least that much. Some languages have much longer aspiration for various reasons, but that's a useful threshold to think of, for example, in the English context. Of course, the other thing that could happen is that the onset of voicing happens before that release. And in that case, we have a period here where we still have the consonantal closure, bilabial closure, but we have voicing happening. So we have a little bit of an actual voiced consonant, B. And so we would tend to transcribe this just as a voiced consonant. Now, one thing to keep in mind here is that when you're between two vowels, for example, if you have what's phonologically a voiced consonant, you will tend to just keep voicing throughout. So it's not just a little bit of negative voice onset, but sort of the voice onset comes way before any of this stuff happens. Um, where this really comes into play for a language like English is at the beginning of a word, particularly at the beginning of an utterance. So if I'm not saying anything and then I go into B, and if I have that plain unaspirated, as an English speaker, I'm going to hear that as voiced. Um, for other languages like French and Spanish, you will have to have some pre-voicing, some negative voice onset time in order to hear that as a voiced phoneme. Because they're voiceless phoneme, the consonant itself is completely unvoiced, and there's no or negligible aspiration happening there. Whereas for English, you have positive aspiration, positive voice onset time, actual, sort of a little chunk of voicelessness on the vowel for the voiceless phoneme. So if we have none of that, no voicelessness on the vowel, we just read that as the voiced phoneme at the beginning of an utterance. Okay, so that's our zero, positive, or negative voice onset time. What if we flip it around? What if the scenario we're looking at is a vowel followed by a consonant? Now this diagram looks very much like our previous one, except it's flipped, right? The vowel comes first, so the oral cavity starts in the open posture and it becomes closed into the consonant constriction. The glottis starts voiced and it becomes voiceless. So again, we have those two events. The oral event is still our reference, but in this case, it's the beginning rather than the end of the oral closure that is our reference point, and our voice offset event is what we're comparing to that. Okay, and zero voice offset time is what we see here. We have E, so the voicing stops at the same time as the bilabial closure is formed, and we have a straightforward way to transcribe that. We can have positive voice offset time, and that gives us a period of voiced consonant before we go into the voiceless consonant. So this will normally be transcribed as eb. Depending on how the language's phonology works, it might be that the voiceless consonants have a bit of positive voice offset time, so it might be transcribed as eb. This is one of those places where the IPA defers to what's normal in a language. Right? What counts as aspiration, what counts as voicing, will depend a little bit on the language. So unless you're doing an impressionistic transcription where you're sort of coming in with as little knowledge as possible, you're gonna incorporate some understanding of how this particular language works when you do these transcriptions. Okay, and of course, the other alternative is that you have a negative voice onset time, which means voice offset, I beg your pardon. So if the voice offset happens before our reference event in the oral cavity, then we have a bit of voiceless vowel. And we actually transcribe this with the same symbol that we use for aspiration. In this case, we call it pre-aspiration. And this does happen in some languages like Cree and Icelandic. So that gives you kind of a diagrammatic visual way to think about things like voice onset time and the difference between these voiced and voiceless sounds in particular contexts. Okay, so I hope that's helpful at getting a grasp on this particular aspect of phonation on consonants.